Alright, good afternoon everybody. Today we're going to talk about oscillations in the lab report number 4. The purpose of this lab is to use Newton's second law to observe the motion of an oscillating spring due to the gravitational force and spring force. We are also going to certify the energy principle, or in other words, we're going to check it using Python. The result: it was verified that a system in equilibrium has a change in energy equal to 0. The overview of the experiment. The system is the mass plus spring plus earth, because the interactions between them have corresponding potential energies that we can use to describe them. We will consider no surroundings acting on the spring, and this way they will be in equilibrium. The fundamental physics principles involved are Newton's second law and the energy principle. The data. The initial time was 0 seconds, the initial position was negative 0.1 and negative 0.6, and all of this data was taken in tracker, and which we will see now. As you can see, the calibration stick is right here. It is 0.7 meters, and the coordinate axis was located here. If we play it, we will see how the mass of the spring is moving in an oscillating form. Here are the values. This is the time, this is the initial position in the x coordinate, and this is the initial position of the y coordinate. Now this is the procedure we used to calculate k, the spring constant. We know that the period of oscillation is equal to 2 times pi times this, and so when we solve for k, we will get that k is equal to 5.85 newtons per meter. And to calculate L0, we have to remember that the net force equals 0 because the system is in equilibrium. There is no energy transfer from the surroundings or to the surroundings with the system. So we set equal, the forces are equal, and then we solve for L0, which we got is 0.027 meters. Now with this information, we can now develop the code for the movement of the ball. Here you can see the code in itself, the initial conditions, and the delta t we chose, and here we are calling the values we got from tracker in this Excel file. These are the x values and these are the y values. If we run this function, we will see the movement of the spring here and the graph of how it is moving. Now the red line is the motion of the tracker and the blue line is the predicted motion of Python. That graph, we were using the x positions of the mass of the ball, of the spring well. Now in this second code of tracker, we used we're going to represent the energies, and we did that with this code right here. Now we're going to run the code. And you can see that delta K is the blue line, delta U, delta potential energy, is the red line, and the yellow line is delta energy, which you can appreciate is 0 all the time. Now, to answer the what does it mean question, is the energy principle satisfied? It is satisfied because from our observation of the Python window, we can observe that the energy principle always remains at 0. The change in energy remains at 0, which means that the system is in equilibrium, satisfying the energy principle. Compare the two estimates of k, of the values in x and the values in y. Notice how the left one is the change in the values of x, and you can see that the amplitude is much higher than in the values of y, because in y it had very little separation, very little change in its movement, and in x it moved a lot, so it takes more time in x to complete a whole oscillation. Thanks for your attention. I hope you learned a lot today.